Okay, let's look at the second type of polymerization reaction. And this one's called the condensation polymerization reaction. In this case, we start with two monomers, and they don't necessarily have to be the same monomer. But between the two monomers, we form a covalent bond, and we also, as part of the process, liberate a small molecule of water as we create that polymer. Let's look at an example. On the left-hand side, I've got 1,2-ethylene glycol. You'll notice that it's a diol. It's got two OH groups, one from each carbon. And on the right-hand side, we've got, in this case, we've got a diacetyl molecule. It's got two alkanoic acid groups, one on the left, one on the right, with our benzene molecule in the middle. This one, we shorten the name to terephthalic acid. And it's important that these two molecules both have two functional groups that are the same. As we put these two together, we'll get the hydrogen from the alkanol group on the left-hand side, and we'll get the alkanol group, the complete alkanol group, from the acid on this side, and they will form together to give us water. And because they've been liberated out of the system, it allows us to form this ester linkage between our two molecules. So you'll notice I've got my alkanol group still on the left-hand side, but I get this COC group here, which is our ester group, formed in the middle between our two molecules. So we form the bond between that particular one and that particular one through this ester linkage. Now, as I said before, it's important that we have a diol, or we have the same group in the one on the left-hand side and on the right-hand side, so it allows us to continue this polymerization reaction. And if this particular reaction keeps going, this OH group could interact with another one of these molecules and the process continues, or at this end, this particular group could interact with another glycol molecule to keep the polymer growing at this end. So because this is an ester linkage, if we continue this process, we form a polymer that we call a polyester, and they're quite common as well. And this particular molecule we call, or this particular polyester molecule is known as a dacron molecule. Let's have a look at another condensation polymer. In this case, I've got an amine group, and you'll notice it's a diamine. So the same way for our previous molecule that we had a diol, we've got a diamine, and we've got a diacid once again in this case. So because it's a condensation reaction, we will liberate water, but this time we'll form a bond between the nitrogen and the carbon. And this particular linkage here is called an amide linkage. And once again, we can keep this chain growing on the left-hand side or the right-hand side between the interaction of the NH2 group and the carboxyl group on this side. So if it's further polymerized, we call this type of molecule a polyamide. Now, polyamides are very, very strong molecules, and they're strong because of the possible interaction between that hydrogen, which is slightly positive, and if we had another chain between this particular oxygen here, which is slightly negative. And because they're very strong polymers, we can use them structurally, and one example of this is our nylon molecule.